Welcome everyone. In this video we're going to look at the difference between mass and weight.
By the end of this video, you'll be able to explain the difference between mass and weight. And note there is a summary slide at the end of this presentation.
When you get on the bathroom scales at home, they will give you a number in kilograms. And kilograms is what we use in science to measure mass. However, when you're at home, you'll normally call that your weight. But that's not what we use the word weight for in physics. Weight has a different meaning that we're going to look at next. So what you're getting from your bathroom scales is your mass in kilograms, and essentially that's a measure of how many atoms there are in an object, or how much matter there is in your body. And so of course, if you were to go to this institution, you're really concerned about the number of atoms of fat in your body, and so it should be called mass watches, not weight watches. Weight, however, is the gravitational force acting on an object. Now we've come across gravitational force before. We know that it's measured in newtons, it's got symbol F because it's a force, and we specifically give it the symbol F(g), meaning gravitational force. In the last video we looked at a whole range of gravitational forces, and we could have just as easily called those weight forces. This is the specific meaning of the word weight in physics. It is the force due to gravity. Now the relevance of that force is it links to how hard it is to lift an object. So if I try and lift the rugby ball, it's pretty easy because it's got a small weight force. If I try and lift the person, it's a bit harder. And if I try and lift the plane, well that's pretty much impossible because it's got a really large weight force. So if we look at the weight force acting on these two objects, obviously the weight force acting on the green car is a lot less than the weight force acting on the fire truck. And so the green car is a lot easier to lift than the fire truck. The other thing we want to be able to do is get these objects moving. So if they're both stationary, obviously I need to push on them to get them moving forward. And if I push on the green car, I need a lot smaller force to get it moving, whereas I need a much larger force to get the fire truck moving. And this is due to inertia. Inertia is a measure of how hard it is to change an object's motion. The green car has got smaller mass, therefore it's got less inertia, so it's a lot easier to start it moving. The fire truck has more mass, therefore more inertia, therefore it's harder to get it moving. I need a larger force. But what would happen if I was to put the fire truck on the moon? Hopefully you all know that the strength of gravity on the moon is a lot less than Earth. In fact, it's about 1/6, so my weight force would be 1/6 smaller. Therefore, it would be a lot easier to lift the fire truck on the moon than it would be to lift it on Earth, because the weight force is less. But what if I wanted to push the fire truck and get it moving forwards? Well, because it has the same amount of mass, it has the same inertia. So it's going to be just as hard to push the fire truck forwards on the moon as it would be on Earth, because they have the same mass. There's still the same number of atoms there. Now you may recall from our learning outcomes, we're also looking to know how to calculate the weight force. And the weight force depends upon the gravitational strength. And different planets, moons and so on have different strengths of gravity. The formula we use is Fg, standing for the force of gravity, is equal to the mass of the object multiplied by the gravitational field strength. And that's always given to you. On Earth it is 10 newtons per kilogram, which is nice and easy to remember and use. On different planets, it is of course different. Here's the summary slide that I promised you, looking at the differences between mass and weight, and you should make sure that you've got all of these points copied into your summary.
So now you know that mass is measured in kilograms and relates to the inertia of an object, or how difficult it is to get the object moving, while weight is measured in newtons because it's the force due to gravity, and that relates to how difficult it is to lift an object up.